Okay, some of you don't understand. So if you look at it, there are switches here, right? You see there's a switch. Right? Then if you look at it, so look at it, everyone should look at it. See there's a switch. Have you seen the switch? Yeah, this one. Yeah. So this one is the power supply. Then these chips are voltage regulators. These ones are voltage regulators. Right. So you see the bottom I was talking about. So we have this here. And if you look at it carefully, you can see that there is 5 volts here and there is 3 V3 there. So look at it carefully. You can see 5 volts here and 3 V3. Right? Have you seen it? Good. So if you switch it here, that means that you are connecting to 5 volts. If you switch it here, that means you are connecting to what? 3.3 or 3 V3. Look at your board. If you don't look at your board, you will see. That's why I say pick your board. If you look at the switch, you will see that, right? Please, do we understand? Now, have you seen that they've also written, when you look at it, they've written plus and minus. There is plus on the top and minus on the bottom. When you look over here, there is plus here and there is minus here. Right? So on the top and the bottom, there is plus and minus, plus and minus. When the top of one plus, you see plus here. And then you see minus here. Plus and minus, plus and minus. Okay. Now. Okay. So see something here. When you take your breadboard, let me just show you something. You don't need to fill your own. But me, I'm filling my own because mine is sacrificial. Have you seen how it looks behind? Have you seen how it looks behind? So you see there are just 2 lines and they are all connected together, even though there are different holes here. So that means all these holes are connecting to one, right? And all of these are also connecting to what? One. But you see there is a gap here. That means that this gap, all of this side is connected and all of this side is connected. Please, do you understand? Good. So on your breadboard, when you take it, all of these sides are connected. And all of these sides are connected. All of these sides are connected and all of these sides are connected. The same thing. Eh? Please, do we understand? Do we understand? Okay. So, when you take the multimeter from your friends, you will see a speaker sign. Which is this? Speaker sign. So let me put it there. If you put it at a speaker sign, right, then look at something. Do you hear a sound?
Yes. Because everything is.
Okay, I think we should all come. All of you come. Come.
Hey, S22. S24.
So see something. See something.
Hey, if one would.
Easy. What does it mean? What does it mean? What does it mean? But see something here. If I put it here, do you hear anything? But if I put it here, so what does it mean? It means that all of these are connected, right? Please, do we understand?
Yeah.
So when I put it and they are connected, it will make a sound. Right, but if they are not connected, you see, it doesn't make a sound. So that means all of these lines are connected. Right. You see, it doesn't make sound. But once the free hair could be, it makes sound. That means. Okay, so let me put this one here. Once I make it sound. Is it make sound? Yeah. Now let me put it here and here. Does it make sound? No. So you see that when I peel behind, you could see that that part is separate. You see there's a gap here. So all of this part is connected and all of this part is connected. Please, do you understand?
Yes.
What do we use it for? We use it for power. Power. You produce power. You see, when you look at this, you can see this is plus and minus, right? So this thing, it can really hurt you. I'm not in a fight. So those of you that have HIV/AIDS, please, I beg you, don't touch it. Otherwise, you infect anyone now. Oh, it can shock you. So if you want to put it in, I will say insert. Bad boys and girls. So if you have put it in, right? Cut this is this. Right here. Give me. See this. Can it enter? Is it can enter? Because when I was buying it, I bought for this one. I didn't know that it was for this one. I thought say anyway so far. But when it came now and I'm using the channel for 9 so you need to cut. So may I cut mine so that I can do this? Please, you understand?
Yes.
Are we here? So now, when you do that, see something here. You see that there is 5 volts here and there is 3 volts here. So I beg you, all of you, just put it all at 5 volts. Both of them. Don't put them at different volts. Otherwise, you can easily burn it. You guys are not experienced. When you become experienced, you can use it. But for now, just put them at 5 volts. Is that right? Please, are we here? Now, please, I beg you, never connect both this and this. Never connect positive and negative together. You see this positive and this negative. Never connect both of these together. If you connect them, it will catch fire. Yes. It will burn. The moment, the next thing you see is smoke. We all see how coffee and no one try. No, because it's having something.
What?
The female is having a hole. So there is a female part. This one is called the male nose.
So where is it?
I didn't buy the female.
Hey,
I was born in the This one here. This is a female.
Hey, I'm sorry, today I was sitting
It's a hole. Hey, come on. So put it here. Red. Let me just put it. Shena. I'll try for you to see. Ghana, for if you don't try, you won't see. No, there's nothing. You see, there's nothing. So when you're putting it in at times, you have to be careful. Otherwise, it will break. Never make sure that, never let it touch like this.
Why is this on?
You let me turn it on and let me just try. So look at this light. Look at this light. See something. Look at the light. Once American What's a teacher? What do you mean? What's a teacher? Oh, what's the way any teacher? No, that man can't check. Me the catch ya. Where me the catch to a ground jet. Me the catch and pet over to pound. Yes, so someone needs to try the you see the way the back is. How's the way the back and pussy? And our way pussy goes this way. Yes. So what it means is that all these holes are one. And all these holes are one. So all of these holes are one. All of these holes are one. But this one, all of these holes are one. Please, you understand? Why do we do it that way? Now let's connect the circuits that I've built on the board. This one. So look at me closely. How do we connect it? So let me just put this one. Right. Are we here? So we connect one end of the resistor to high, right? To 5 volts. So this is 5 volts. We put it at 5 volts. So I connect one end of the resistor to high. And that is this end. So you see all of these are connected to the same. Yeah. So if I put it here, that means I've connected that high to it. That's why we make it up. Then from the resistor one end to the what? The LED. Right? The positive end of the LED. And which one is the positive?
The long one.
So the long one comes. And then the shorter one. So I connect the other end of the resistor to the what? Please, have you seen it?
Yeah. Yes.
What else? Wow.
Yeah.
Black one, I'm a ground. Black ground. Let's go and take
class of attendance.
Look no pedal.
Hey, look.
So
Cameraman.
Now, have you seen that is now on?
Yes.
So let me organize it. I would like to do this one. Now, see something here.
Wait.
So let's see. Let's come in. Let me take this one out. Put it here. So this one. You see, this is amber. Right. You see there are two different colors.
Yes.
Amber and yellow. Let me add another one here. I don't know what color this is. So, on the answer.
Infrared. Not serious.
Infrared. Have you seen that it turns on small?
Yes.
Then let me try this one.
Me.
Hey, where did the punchline?
Now, see something. This one is amber. Have you seen what is happening?
Yes.
One will say me connecting red and amber there, a soy. But me connecting amber and white and so.
Why? It's why.
But once I'm connecting the yellow,
Why? Because they.
but me two are winning a free one. Now how it's number.
Say why?
Hey.
The power.
Hey.
Say explain why.
But me the white need blue. A shame one. Oh. In our heading.
Ah, okay. Interpret is for the green. Like, when you know what they say, they 2.8 and I will need 1.8.
What was that with the red shimmer? No money now do.
Yes.
With the red shimmer, no money now do. I mean, too red, no more me no. Why? Why this? That means if you want to do if you see, I was telling that if the voltage is let's say it's starting from 0, right? When it's starting from 0, it gets 1. Then it gets 1.8, 1.9. Then the red one will what? 10 on. Quick. But look at how we've arranged it. So we have. When this one gets to 1.8, how's the wave so? Wave it me out. And we're on the day. But when this one turns on now, 1.8 account, and the country says, we saw 1.8 account. It's a rising ground, who could still now 1.8 account. 1.8 now, because this one is in parallel with it, you see voltage is the same. So it's 1.8 that will come across the white. And can that one turn it on? Yes. Please, do you understand? Yes. So your first assignment in this lab, your first lab 1, is to build a schedule that will turn on all the different colors. So when you go home, just use the voltmeter to know the colors, the different colors. Some of you would have 6 different colors. Some of you would have 4 different colors. Some of you would have 5 different colors. So your first lab assignment is to build a circuit that turns on all the different colors that you have. Please, do you understand? I'm not saying all the legs, I just want to see different colors. See white, blue, green, red, amber, just 10 all of them. Then you take a picture of it. And that's lab 1. Then you post it on LinkedIn. Then you start. No, you need to describe what I said. What is it? It's a secret. You need to put on. So you will show when you connected all of them together in parallel, it wasn't working. Then when you put this, it doesn't work. Then when you develop different circuits for this, it works. Then please, do you understand? So that is lab 1. Now we are done with lab 1. Lab 2 will be on this. Lab 2 will be on the transistor. So I'm going to get down with the transistor. So the lab instructions I will send you will be on lab 3, 4, and 5. And those ones will be one on this, one on this, and one on this. Those ones are difficult. But then, what I need, lab 2. In fact, I think 6 labs, you can do 6 labs. This one too. Where is it? This one. Have you seen this one? This one is what you can use to build the automatic light. When the room is dark, then it will turn on the light. When there is light, then it turns it off. So you use this and this to build the transistors. So let me talk to you quickly about this, then we are done. This one. This one is called a transistor, right? So let me talk to you about a transistor. Please, are we here? I hope you understand this one. You understand it? Very simple. You guys are brilliant. Now let's talk about this. Anyone having a tissue here? This one, we call it the buzzer. Let me turn it on and let's see how it goes. Buzzer. Buzzer. That's how it is. But the 555 channel will not let it do ping, ping, ping. So let's build one of that circuit right now. C is the one here, P and E, not pointing in, NPN. So this one is called the NPN transistor, not pointing in. The one I called for you, its name is this. 2n2222A. 2n2222A. So you see that three letters. The one in the middle is called the B. The middle. The middle one is the base. Then if it's facing you like this one here is C. The one here, if it's facing you, the one here is C. And the one here is what? E. So CBE. 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 If you forget to just write that name there. NPN see it as a switch. That if you pass current here at the base, then this one will close. If there is no current here, it's open. Please, do you understand? Do you understand? So if there is current flowing here, then this one will close. If there is no current here, this one will close. But the problem is that for the NPN, the amount of current that they will allow to flow here depends on the current here. If the current here is small, then the current that will flow here to the water small. So you see that if I turn this circuit on, it is very loud. Very loud. Now see something. Do you hear the sound it's making? It's making sound, but you don't hear it. Very low. Because the current that I made to pass here was small. So the current that is passing here for the alarm to go is what? But you need it so that the circuit will work. Right? Are we here? Are we here? So let's do the first step. Step number one. Step to bias a transistor and NPN transistor. Step to bias and NPN.
I need 20 months.
And that's the only one that's okay, great. Step to bias a transistor. So what is it? I should have brought my microphone. So that you would have added it to it.
Okay.
I have some nice microphones in there. Number one, identify the current you want to flow in.
Boy,
We call that IC. You see, this is a collector. Right, so the current flowing through a collector, we call it IC. So identify IC, the collector current. So IC, find it. Let's say that for our buzzer, we are using an IC of 50 mA. Right? So if it is an LED, what will be IC? If it's a LED, what will be IC? 20 mA, right? So for a buzzer, let's use 50 mA. So let's say IC is equal to 50 mA. So you identify IC. Identify IC. Now, let's look at this leg circuit. 5 volts. Alright. So it's just this. When this guy closes, the circuit is working, right? But we want to find a resistor here that will allow an IC of what? 20 mA to flow through. Right? Right? Good. So we are going to find R to be 160, which is equal to what? 150, just like how we calculated it. Right? So in this case, this one will be R's because it's connected to the collector. Right? So you first of all find IC. When you find IC, for a transistor, this is the behavior. It will take anything flowing here. You see, I show you that what you put here is what is going to be amplified. So what is here is a base, so we call it ID. So it will multiply ID by a certain fixed constant called beta or HF. Then you get the carrier in IC. So if we want an IC of it, what should be the ID? Right? So that we have IB is equal to what? IC over B. For this transistor we are using 8B is between 100 and 300. So we are going to use the minimum, the smallest one. Right? So we are going to use B main. And so this is going to be 50 MA over what? 100. And that's going to be, what do we get? What do we get? Microamperes, right? Now, will it be 5 microamperes? Find it for me. So 1, 2, 3. So that would be, oh, okay, so 1. That would be 0.5 microamperes, right? Is it 0.5? Yes. 0.5 microamperes. You see that current is very small. Current in it is very small. So this is called IBA because of this. Now the minimum current that needs to flow in the base. Now what that means is that if the current flows lower than this, you will not get what you need. Right? Any current that is lower than this, than 0.5 micro, you will not get 50 here, and then you will behave the way you want it. Please, we understand. So what we do is this. We will say that, okay, because of that, we are going to multiply this one by a certain number so that we know that at least it's always more than this. So we can get a carrier that way. Right? So usually we multiply by a safety factor of 5, between 5 and 10. And just pick any number. That's the third step. So this is IB, then you do IB design, which will be a safety factor times IB. So we have 5 times 0.5. And we are going to get 2.1. 5 micrograms. Is that right? Are we here? Then after you get the carrots, you will now come and calculate, okay, if that is the case, what resistor should I put here with the voltage here so that I'll get that carrot that I want? Is that right? Are we here? Are we here? Good. So what if I put a certain voltage here? What resistor should I put here so that I'll get this current that I need to flow here? So it's very simple. We use the formula, and that's the formula final step. Step 4. RB is equal to that VB there minus. There is a diode here. When it turns on, it latches 0.7. So we need to subtract that 0.7. So minus 0.7 over what? IB. So if we are using 5 volts to switch, if VB here is 5 volts, like I've told you, that means it's going to be 5 minus 0.7 over what? IB of what? 2.5. And what will it be? Yes. It will what? Be very careful. 2.5 micro. How many micro now are we waiting? Yes. So it's very big. 1.7 mega. Or wow, it's very big. Okay, so we need something like 170K. Right? 170K to be able to get a current number. Please, do we understand? Which one? Okay, so just take it like, right? Just follow it. Is that right? Please, is that right? This one, right? So just take the steps and follow it. First of all, what is the current that you need? I need a current of what? 50 mA. So IC is this. Then you just follow these steps. It always works. If you follow it, it never fails. Please, do you understand?
Yes.
Are we here?
Yes.
Good. So now let's go on and build this circuit. Let's build it. Let's build it. So there's this circuit that we are building, right? This one thing. So this is our transistor, right? This is our transistor. 3 terminals. It's having, when you look at it this way, here is C, here is B, and here is E. Before on his first time, there's anything. Intino. The share. It's the higher C, B, and E. Now, Shadia, transistor. To make buzzer. So let me just put it here. The end no back C little.
Say, please, what's the essence of the buzzer?
The buzzer is to alert. It's just to make noise.
Okay.
Alarm. Like this. Now we have background. So this is a transistor.
It didn't come like that, right?
This is a transistor. Then this one comes to now after you have a base, once the resist the young connected base. It is a mesadi we are and so right because there is nothing at the base to the main so.
This is the virgin.
Yes, just follow now. That was all. Okay, this shouldn't work, unfortunately. That means I didn't connect it well. So let's go back. So so now let's build the other hers. These are my resistors. 150, 1 mega, 680K, 470K, 300K, 200K, 100K. So let's pick 100K. Then we'll take one of this. Then we'll put this one. I can connect this. Yes, that's a resistor. Right. Then let me take the white bees. There is one here, right?
It's the same.
This one here.
Child, national.
Then I
Mama,
take
come and do your job.
So let's go and look at this one. Transistor is probably how it's not how
We like the money. Like it shouldn't come.
it shouldn't come unless I turn it on.
I know, right? I've not even seen that. Change the button.
Lois sorry. Mama Lois sorry. Are you married? Yes, it's on me.
Wait there, mom's in the cannon and money go.
Wait, it's not okay, right?
Five, and I'm getting the corner back on the hole. They go look at you.
Because I guess I want to come out.
I'm not close to 12 o'clock. Let now. 12 o'clock.
Because it's
So
Maybe one.
change the
And you
At least. Right.
go use it.
so it's
Nah, of course.
okay. Oh. So you see that now me man for we and shemo a enye djuma me de she we mo na ye djuma Matia say oh man for we and shemo a no aso ba wan say enye dede this e bi am the way here dem e ma 5 vote pasana say Matia say enti me connecting wrong. What's me done in the eye? Me connecting wrong. Who connecting wrong? You need to send this. What else? It's electronics. Yes, and it's you connecting wrong. To me, you will free more. Oh, that? Now, in your last one. They say, yeah, alarm money, pay.